Assalamu alaikum to everyone. I hope you are all fine. Today we will start matrices. In this video is more helpful for you to understand matrices and their solution. Now, chapter 7 matrices, page number 155. Chapter 7 matrices. Before going to exercise, we will learn about matrices. And matrix is an arrangement of objects, numbers or variables in the form of rectangular array. Its elements are written within square brackets in a definite order. So you know that variables and constant means those numbers which are 1, 2 and 3. Natural number, all natural numbers is, and the variables are alphabetic numbers A, B, C. So these numbers of arrangements which make an array, a rectangular array. You know that rectangle means this type of shape, so two sides are equal, and square this type of array is we will return. So here is elements of matrices we will write inside the bracket. So now we will further study about this topic. Now we will suppose a company supplies two of products P1 and P2 to two of its customers C1 and C2. The company supplies 20 units of products 20 units of its products P1 to C1 and 30 units to C2. It also supplies 25 units to product P2 to C1 and 15 to C2. This can be represented by more compactly as follow. You know, in this array, this is the square brackets. So inside of square brackets of its elements. Now this statement we will write in the form of this. So P1 is company, so with product of P1, and C1 is the customer C1 which supplied 20 units. So we will write here now P1 a product which supplied to customer C2, so which is write in 13. So in these matrices the array of this is called matrices. Now the elements of inside the matrices is called element of matrices. So matrices we will represent it a different alphabetic capital letters. Now we know that the matrix is the arrangement of such type of this number. This is a example for helpful to you understand what is matrices and how to write matrices in the form of this array. So these brackets are array, so inside the elements of this matrix is elements of array. Now we go to further next. Now notations, it means the matrices are represented by some numbers. Matrices are represented by capital letter of English alphabets. Now for example, this array we will represent it by its name of a letter capital A. Now this element of matrices is L1 2 array which is represented by capital letter B. Now X means a letter X, Y, Z which is represented by a number, so we can call a capital X. So Y, so AB, this is the element of matrices we represent by Y. Now notation means a matrices we can represent by a capital letter of English alphabets A. So the inside of matrices you can write a small order of, you can A be the small, so Y is a capital letter, so is the array of these matrices. Now order of matrices. order of matrices if there are r rows and c columns. So here r means rows and c means columns in the matrix. In a matrix, then a means a matrix A, then order of matrix is r cross c, so means r rows and c columns. Consider, let's suppose A is a matrix, its elements under the root 3 minus 5 0 2. In order form, we will write order of A is 2 by 2, which means called 2 cross 2 or 2 by 2. It means that two rows means 1, 2 rows here, and 2 columns 1, 2. So we will write first rows and second columns. Okay, the order of matrices is 2 by 2. If B is 2 by 3, then order of matrix is 2 cross, his 2 rows, sorry, his 2 cross 1 column. 1, so is typing mistake. So we can write 2 cross 1 matrix. So is the 2 rows and 1 column. So here again, even you further more examples we will take. So this is again 2 rows 2 columns, again 2 rows 1 column. So we can write here 2 by 1. So again we can here write here 1 2 3. So here 3 rows and 1 column. So this is 1 column. Here again 1 row 2 columns. So we can write here 1 row cross 2. So order of matrices we can write in this form. Okay, I hope you will understand. Now type of matrices. You know that type of matrices, first rectangular matrix. So rectangles, with the word we you know that rectangle means this type of shape. Okay, so it means two rows are two sides are equal. If a number of rows or number of columns are not equal, the matrix is called rectangular matrix. So it means that two rows, matlab here columns are not equal, the matrix is called rectangular matrix. Now I will consider a matrix x is equal to x y z. So it means an one row and 3 columns. So here order of matrix is not same, because 3 rows and 1 column. Here again 1 row 2 column. So this type of matrices, so order of matrices are not same. So rows and columns are not same. Rows is not equal to columns. So this type of all type of matrix is called rectangular matrices. So again here order of matrix we can write here 3 by 1 and y is equal to 1 row and 2 columns. Okay, this type of matrices we can call the both matrix column and row are not equal, which rectangular matrix is row not equal to column. Next, column matrices. You have already understood rectangular matrices. Now if a matrix has only column, it's called column matrix. So column matrix means only one column of in matrix. Consider A is equal to C1, which means one column. Here again one column. So here again one column, but here again 2 columns. So which means if a matrix has only columns is it's called. So with only columns, not one column, so only columns is called column matrix. So but we can take here 2 rows, we can take here 2 rows, but here only column matrices. So it's called column matrix, or example of column matrix. Now next, row matrix. If a matrix has only row, it is called row matrix. So row means are only matrices which will be represented by a row matrix. Consider C is one row here, and the order of this matrix is 1 by 2, and C is equal to 9, which is one row and one column. Order of matrix is C is equal to 1 row. Now C is equal to 1 cross 1. So here one column and one row. So this type of matrices is only a row represented is called row matrices. Now square matrices. Square matrices, if a matrix has on number of rows and columns are equal, then matrix is called square matrices. Now square matrices means here two rows, and this is the square, this is two sides are equal. So here again the sides are equal, rows and columns are equal, so we can represent it the square matrices. So okay, now here A is a matrices represented by 3, 6, 5, minus 9. So is the column C1 means one column, but here again row and column. So here 2 by 2 matrices. So these two rows and two columns are same. So here again 2 rows and 2 columns are same. And C. So again we will take this example 100. So it means one row, one column. So it means this is also square matrix is 1 by 1. When rows and columns are equal, row is equal to column. So these type of matrices is called square matrices. Okay. Now in this example, diagonal matrix. When diagonal matrices are square matrices in its all diagonal elements 0 except elements in leading diagonal. So leading diagonal means matrices. Now this is a matrix A and this is a matrix B. So here elements of this matrix is a row, and B is equal to 2 rows and 2 columns. So here diagonal matrix means this is the diagonal elements. So a square matrix is the square matrix in its all diagonal elements 0 except elements in leading diagonal. So leading diagonal means this is diagonal. So leading diagonals 6 minus 6 is leading diagonals are not 0 but different it may be, but these numbers diagonals elements will be 0. So these of number is square matrices is and the diagonal elements. Now scalar matrices. Scalar matrices are the whose diagonal elements are equal in its called scalar matrix. So scalar matrices A is equal to 3 by 3. So this is square. Now the diagonal elements 3, 3 are same. So here D, D. Diagonal matrices are same, but the leading diagonal elements and leading diagonal DD is same, but diagonal elements, this is diagonal element and this is the leading diagonals same. So with this type of all matrices is called scalar matrices. Now null matrices are 0 matrices. Now we know that null matrices is the type of matrices which is 0. So a matrices whose all elements are 0 is called null matrices. Null matrix means these are all elements is 0. So this is again a matrix which is A 0 0 0 all elements inside the array which is 0. So this type of matrices is called null matrices. So again, next unit matrices. Unit matrices means a matrices of the form of this. It is called unit matrices 2 by 2 scalar matrices. So all elements of this matrices is 1 1 and 0 0. So leading diagonals and should be 1 equal to 1, and these diagonals are equal to 0. Now exercise 7.1, page 158. Now exercise 7.1, fill in the blanks. Question number 1. Here A, B has the rows and dash columns. So we can write here one row. Here we can first of all here 2 rows and 1 column. So we can write here 1 row, 2 rows and 1 column, because AB is first row, is first column and 2 rows. Next AB here again is first row and 2 columns, so has dash rows and dash columns. So we can write here 1 row and 2 columns. Now question 3. Order of 5 0 5 3 5 is dash. So here can write here 5 0 5 is first row and 3 5 second row. So we can write here 2 rows multiply 1 2 columns. So it is square matrix. So it's 2 rows and 2 column matrix. So order of this matrix is 2 by 2. This order of this matrix is 3 under the root 2 5 7. Again this matrix is 2 by 2 matrix because 2 rows and 2 columns. So it's square matrices, you can represent it by 2 cross 2. So it is a square matrices 2 by 2 matrices. Again 3 is a dash matrix of order. Now in this elements is only one element and which is 1 row and 1 column. So in this is a square matrices is order of 1 cross 1. So we can write here 1 row and 1 column. Now 5 7 0 7 is a dash matrix. So here this is a scalar matrices. So 5 7 is the scalar square matrices. So we can represent it by a diagonal matrices are 5 7 and 0 0. So it's a square matrices. Is a you can use diagonal matrices. Diagonal matrices. So diagonal matrix we can write here diagonal matrices. So next again here, if a number of rows of matrix A is equal to the number of column, so then A is called dash matrix. So we know that we will take example this. So order of row and column are equal. So this is rows and this column. So both column and rows are equal. We can call square matrices. So you can write here square matrix. Okay. So next here question number 8 in A B C D. So here again A is the 1 row here and 1 row here. So this is the 2 rows and the element of first row and second column is. So in this example we will take first row is A and first column is this. So the intersect of this line is in A. So A is the, so here A means first row and second column. So first row and second column here. So the B is the element here, first row and second column intersect. So we can write here B, because in a, you know that we will take example for this question which is most helpful for you. Okay, this is the array. First of all, I will take example. Now this square matrices. So we can write here some elements A, which means I can write here one row, one column. So these elements in the matrix is first row. This is first row, which means row 1, and so here we can write here row 1 and row 2. So we can write here row 2. So first row, first column. So again we can write here elements first row, second column. So which means first row C1 and C2. This is second row and second column. So again here we can write here a second row, first column. So means we are second row, first column. So we can write again here second row, second column. So the element of B means here, so second row here, first row means this, and second column means this. So the elements of B in this number is B. So first row, second column we can write in this form. Okay. Now we can write here as first one row. You can write here two rows and one column. Again we can write here one row and two columns. Okay, so we can in this equation order 2 multiply we can write here 2 multiply 2. So we can write here 2, and now again this is the order of matrices. We can write here 2 cross 2 2 cross 2 matrix. So again this is 3 is the dash order of matrix. So we can write here 1 cross 1. So you can write here matrix of order is a dash matrix. So this is a we can write here diagonal matrices. So we can write is a diagonal matrices. So if our number of row is equal to this, we can write square matrices. Square matrices. If all of first row and second column, so we can write here B. This is element of first row and second element. Second element is B. Now question number 2, decide where the elements are true or false. Decide where elements true or false. Justify here. Now question 1, 3950 is a square matrix. So it is a square matrices because 2 rows and 2 columns are same. Now question number 2, 7001 is a scalar matrix. So we know that scalar matrices all leading diagonals equal must be same. So 71 is not same, so it is not scalar matrices. So we can here take false. Order of 2 plus under the root 3, 6 plus 3 is a 1 cross 2. So it means that here one row and 2 columns, C1 and C2. So 2 plus under the root 3 is one element here, and 6 plus 3 is one element, so it's called 1 by 2, so it is also true. Now 1 0 0 1 is a rectangular matrix. So we know that rectangular matrix is the square matrix because 2 rows and 2 columns. In rectangular matrices, diagonal elements are the same. In rectangular matrices is not order are same because rows and columns are not equal. Rows and columns are not equal in rectangular matrices. So here rows and columns are equal. So this equation is false. Now 1 0 is the unit of matrix of order 1 cross 2. So we know that unit matrix is not unit matrix. So unit matrix, we know that all the elements inside the array must be 0. So there is not 0 elements, 1 0, so order is true, but this is not unit matrices. Okay, this is false. Now, if order of a matrix is 2 cross 1, then it has 1 row and 2 columns. Order of matrix is 2 cross 1, then it has 1 row and 2 columns. So when this not statement is not true, because we will write first rows and second columns. So here first rows, 2 rows means not 2 and 2 columns, not 2. So we can first rows and 2 second columns. So this is false. Question number 7. A null matrix has always a square matrix. We know that a null matrix which has all elements inside the array is equal to 0. So all elements inside the array equal to 0. So it is not square matrices. So it must be equal to rectangle matrices or square matrices. So this is not true. A diagonal matrix is always a square matrix. We know that a diagonal matrix is elements inside the diagonals are a diagonal matrix is a matrix of order 2 by 2 in which all elements are 0 except those in leading diagonals. So this is true. A scalar matrix can be rectangular matrix. We know that scalar matrix is always diagonal matrix, all of whose diagonal elements are equal. Diagonal matrix are equal. So it is false. Scalar matrix can be rectangle. So it is not rectangle because diagonal elements of matrix equal to 0. So this is false. We know that scalar matrix can be rectangle matrices, so is false. Now next, in matrix 5 8 7 is the element is 7 8 are the leading diagonals. So we know that leading diagonals are the elements this. So here not 7 8 is the elements of leading diagonals because the elements are leading diagonals is 5 and 9. So leading is diagonal 5 9. So this is false. So a square matrix is always scalar matrix. So we know that square matrix whose all elements are order in which 2 by 2. So it's 2 rows and 2 columns. So always scalar matrix, square matrix is always scalar matrix.